as we start to talk about improving our camera obscura or our pinhole cameras, what we actually need to start to talk about is the actual optical part, the lens. And lenses were developed in the 1600s, and that's what started to make telescopes possible, and people started having reading glasses and things like that to fix their eyesight, because the eye works just like a lens. It's basically a lens, and it projects the image that we see of the world onto the retina of our eye, and then our brain then takes those rods and cones and sends that information to the visual cortex, and that's where we form that image inside of the brain. So lenses, they've been around for a really long time, and so we're going to look at some basic ideas of kind of how a lens works, and then that way maybe you'll have some idea of what you can use maybe for your camera obscura. So let's start with some basics. I'm going to be using, let's take a look here. So lenses come in all sorts of shapes and sizes, right? And we don't need something like this, like a photographic lens, in order to create something for our camera. Actually, this would probably work worse than something like this for our applications, because this, even though it's small, is meant to project, into a smaller area. And so this probably wouldn't be the best type of lens to use. So what we're going to use, if possible, is a magnifying glass. Now, again, I don't want you guys to run out and get a magnifying glass. I want you to look around the house and see, do we already have a magnifying glass? Is there something around here that we could use that would work like that? Because a lot of people do have something, around the house. Could be an old pair of binoculars that are broken. Could be, an old toy that has like a plastic lens in it for whatever reason. Or, be creative, use some problem solving, and see if you can figure out something that's going to form an image. I picked this up at Daiso because they've got stuff for like $1.25 or something like that. And, dollar stores, those sort of things, could work. But again, I don't want you to run out and buy something. Try to work with what you've already got, because we're just going to use this for this one project and then not need it later. So I'm going to use this one. And what we need to find out is basically the idea of where is its focal point. And we'll talk more about focal lengths and focal points as we go along, but we need to know, how far away is a image that's going to be sharp form. And so we'll look at how to kind of test that part. So before we do that, let's talk a little bit about how the image is actually formed inside of a lens. So let's jump in here. So we're going to look at a couple of different things. So let's start with our pinhole camera just to kind of review. So again, anything that we're doing, we're talking about, a dark box, right? So we've got a closed in surface and an opening that's going to let light in. And so when we have a pinhole camera, let's say we've got a tree out here. A little hole for the squirrels, right? So now we've got this tree, right? And so what happens is, let's say we have the sun over here, because we'll have more light falling on the surface. It'll be better than being backlit, right? So if there's light rays and they're hitting this tree, they're bouncing off of this, and light only travels in a straight line. It was Ibn al-Hazm that discovered that back in the 11th century in Iraq. And so we know that light travels in a straight line. So if light's hitting this leaf up here, it's got to go through this spot here. So basically it's going to create a line that goes right through there, and it's going to project down to there. And then the light that's bouncing off the bottom of the tree, what it's going to do is it's going to go all the way up. And again, it has to go through that same opening, and it's going to project to there. So then what we would end up with is, a picture, and then the tree would then be like this. And there's our tree, but it ends up upside down and backwards. And you should have noticed when you went through and did your stuff with pinhole camera that that's what you're seeing, right? So that's how a pinhole camera works, but a lens is going to be slightly different. So let's take a quick look at what a lens is going to do instead. So when we talk about a lens, what we're looking at is something with a curved surface. So it's not just a flat piece of glass. A flat piece of glass just lets us see straight through it. So we need there to be this curved surface to it. And the type of lenses that we're going to be using are what are called convex lenses, or double convex lenses. So what that means is actually our lens itself, let's say our lens is here, there's a curved surface going in this direction, and there's a curved surface going in this direction. And so what's going to happen is, as light passes through it, because there's this curve, it actually will bend the light and cause it to, to change its direction in order to create a focal point. So let's say we have light rays coming this way. What happens is, when it hits this surface, it starts to slow down. And so then it starts to bend a little bit. And then once it bends, then once it exits, it continues in a straight line. And then same thing this way. So we've got light that comes through, it hits this surface, whoops, too far over, but it'll bend a little bit, and then it will continue at that angle. So when we do that, then this point here is where that image is in focus based on what it's viewing, out here. So what we need to do is to figure out, well, how far away from our curved surface or our lens is that focal point going to be? So that when we go and we set up our camera, what we want is to make sure that when we place it, that we make sure that our camera is big enough that it's going to have enough room so that we can adjust that focus, because we don't want a fixed distance. So part of what your problem is going to be is, how do I maintain the darkness inside of my camera and also be able to move either the surface or the lens so that I can change the focus? Because something that's closer is going to focus at one point and something that's further away is going to focus a completely different place.